Thanks for joining us today. The topic is the floating air 2020 applications and installation and service. Please, as Jared mentioned, please put the comments and questions in the chat box, and we'll get to that at the end of the slide presentation. Application of ductless mini splits. Ductless mini splits are a great alternative to unitary systems, providing 40% less energy usage with a sleek and stylish looking system. What's your perfect installation application? Access to an outside wall, access to above the unit, cassette inducted, access to line sets, access to electrical, access for ease of mounting, and access for proper servicing. All of these, in my experience, are critical when it comes to the perfect installation application. Many considerations to look over the job site when positioning and sizing and installing the equipment. Please try to reference these and think of these often when you're working with the ductless systems. Access and serviceability definitely matters. We all know from being in the field that things can add up to unforeseen costs, unforeseen service-related issues, performance-related issues. All of that does make a difference. So when you're planning your installation, make sure to have its best conversation with the customer. The expectations of the equipment, the understanding of what the customer is trying to accomplish with their cooling and heating needs, and the overall look and feel of the installation, plus future serviceability and maintenance. Can ductless mini splits be installed here? This is a basement picture, finished room, trying to figure out what the best installation practice would be. Best equipment to offer to this customer. Maybe a variety of different installation issues that come up from time to time and would be necessary on planning this project appropriately. System design is critical. Design is defined as the process of engineering an HVAC system. The ductless equipment is heavily focused on load calculations and equipment selection. So make sure that when you're looking at a project to design your ductless installation, all concepts from system concept, load calculations, manual J, proper equipment selection, installing and using proper techniques with installation equipment, and adjusting and testing and balancing. Yes, there are some truths behind sizing charts. They're not just pretty pictures in a book. So similar design and build concepts, you're not going to build a 20-story building without properly engineering the building first and using the proper materials. Similar window design, window sizing and placement, similar insulation, if any, similar layout. All of these concepts hold true today as a question, but we believe it is so. ACA Manual J. The importance of completing a Manual J is to determine the heat gain and heat loss of your specific application. No two applications are exactly the same. Which is so true. You know, window panes, you know, even the ratings over time break down. Calculations of the R value of the wall factor. You know, customer might have a tree in their yard for 20 years and all of a sudden a storm comes along and takes it down, and it changes the whole calibration of how the house is engineered now, because, you know, they had that shaded covering for 20 years that actually did provide some cooling efforts naturally from the environment, and now they don't have that, so their heat load goes way up. So definitely important to do your proper calculations to determine your equipment sizing. Clearance Pro and Premier. We have a 5-inch clearance from the top of the unit with a 70-inch clearance from the bottom of the chassis once it's mounted on the wall. We're also looking for approximately 2 inches left to right from any obstructions, corner inlets, doorway openings, etc. And then 60 inches to the front, so that you're not putting this in some kind of nook and cranny and expecting the air to make its way around it. Clearances again on the Select product would be 6 inches from the top, 78 inches from the bottom, 6 inches from either side, and then 72 inches to the front. Need a little bit more clearance on this particular model. For example, wall penetrations. This is important. How often have we made it where the line set doesn't line up, or we have issues with the drain line? Making sure that the unit is properly pitched. So what we want to do is when you're drilling your holes, drill your inside into out. And once you get through the drywall or whatever wall surface material you have, if you drop your arbor down or you angle your bit down, you should be able to create that nice slope to make sure that there's gravity feed on your condensate. Clearances for the outdoor unit, Pro and Premier clearances. Obviously, we want to be able to work on the top of the equipment and getting to the access panel and the electrical panel on the top, as well as the right side where your line sets connect. You need clearances there to gain for service. Plus, you want to make sure that you're not blocking the discharge air coming off of the condensing portion of that. Shrubbery and things like that also does take into account restrictions. So we want to be mindful of the front space clearances, as that sometimes is important and overlooked in settings of specific application. Clearances of select product, 20 inches to the top, 12 to the side, and then more than 72 to the front end. Obviously, the more space around the equipment you can provide, the better off it is for you to make it easier for you to access it personally. You may not be the technician going back to service it, but you know that you stand a fighting chance that if you have a room enough to work on it, that any future service would be taken care of appropriately. Some of the tools of the trade. Essential tools for ductless installation. The big one is an orbiting flaring tool. Making key flares is critical in keeping the system charged properly, keeping contaminants out of the system, making sure your line sets are connected appropriately. Often overlooked is a torque wrench, to making sure that the flare nuts are properly connected to those points of contact and making sure that we have good, clean connections. Deburring tool, some guys use a razor knife, some guys use a pocket knife, whatever. But a deburring tool to make sure the copper tubing is clean when we make those flares. Vacuum pump, 2-stage or other appropriate vacuum pump. Good for pulling down a vacuum, making sure that the system is clean before we charge the refrigerant. Micron gauge, making sure, once again, as a refrigeration tool, to making sure that we have good, clean circuit refrigeration system, and that the system as clean and as free of contaminants as possible. And a good manifold gauge, whether you use a digital gauge or the standard analog type, making sure that you have good, clean hoses and that you're not contaminating the potential system with any, undue components. And then a digital refrigerant scale, fish scale, bathroom scale, all of that stuff should be out the window by now in the conversation of speaking, that to properly charge and add refrigerant and remove refrigerant from a system, you need a nice, good working scale to make sure that those charges and refrigerant measurements are accurate. Line sets, making sure that both line sets, some guys will run their own line sets, so they'll get strips of rolls of copper and then they'll get the bare Armaflex or insulation and make up their own. That's a fine practice. Sets are often purchased with equipment that they're already pre-done up for you. The idea here is that you want to make your own flares to verify that you make good, clean connections. How oftentimes in the field have we purchased a flare, a pre-flared line set from a supplier and got to the job site and the the flares or the copper was a little thin and the flare didn't hold, or the wire or it just didn't meet your specific specifications. So nice thing to do is get your line set ready and make your own flares to make sure that you feel good about the connections you've made. The power and communication wire. This is always a debatable idea about what wire I can use. We in our literature recommend 600 volt rated wire, 14 gauge 4-wire. That's 3 conductors and 1 ground. Do not intend to use the ground wire as one of your communication legs or power legs. That is so often a mistake. We want to make sure that the wire is also stranded, THHN, and in some local codes require that you put that wire in conduit, and making sure that the wire is shielded preferable, to eliminate and reduce any electronic interference that may affect the equipment. Neon signs, in plenums, high resolution televisions, radio transmitters, high ballast fluorescent lights, a variety of other electronic components, modems, fire system repeaters, etc. There's a numerous number of potential energy interference systems inside a building and now inside homes with the the evolution of all of the high-end HD TVs and things like that, and modems and routers and everything putting out signals. So security systems and what have you, fire monitoring, all kinds of equipment. So if you're using the proper shielded wire, that reduces your chances of any of that interference affecting the equipment. And then the condensate drain line of choice, whether you're using PVC pipe and your code requires that it be hard piped, or you're using a corrugated drain line, or in some cases you'll have to use a condensate pumping system based on your specific installation. Line set and electrical routing. After you drill your hole and mount your unit, you're running your drain, and preferably on an outside wall. So you're out the building and then down the side through a chase or line set cover or what have you, right to the condensing unit. Based on the length of your distance between your wall unit and your outdoor condenser would determine how much line you really need. Excess line is not necessary nor required. You might leave a little slack on the end of each wire to make a proper connection and give yourself a little working room, but any significant excess should be avoided if possible. Making sure that both copper lines are insulated. You might see in operation that if you haven't insulated the wire, the refrigeration lines correctly, you might get some sweating. Sweating might lead to biological growth or discoloration of the wall or some other leaking inside the sheetrock or what have you, and could create some other building system issues. So make sure that those lines are nicely neat and clean and insulated. And also make sure you can run the communication wire along with the line set, and that doesn't have to be run separately. Evaluating the length of line on the fittings. So yes, 90s and bends do create extra length. For example, a 1/2 inch 90, you would subtract a 1 foot length from your total line set. So this is important in trying to calculate the proper charge of the equipment and making sure that once you meet the minimum footage of the equipment that you need to add additional refrigerant. Knowing the number of counts and the size of the 90s will certainly help correct and making sure that you have the accurate charge of the system and how much additional refrigerant may have to be added. Yes, the rubber plugs. This is a common thing that we put the lines together where we haven't used our own flares. We use the factory flares provided by the line set manufacturer, and we forget to take these little plugs out. The purpose of the plugs is just to keep contaminants from getting into the copper. And we put these nuts over the fittings, and then this rubber gets stuck inside the joints, obviously clogging the system. So creating a multitude of problems. So make sure that we keep that copper nice and clean. And like I always recommend, cut and reflare the lines to make sure that my flares are done the right way. And it'll prevent things like this. This plug was jammed past the fitting and almost got drawn into the equipment. Never a good sign, never a good fix, kind of a pain to deal with at the end once you figured it out. Down to drainage. Got condensate leaking out of the bottom. No traps, no code issue. Use an open standpipe like a washing machine drain or a fully vented trap, or making sure that you have the right pitch. Notice here, this is the bottom of the line, and the drain, this pipe is actually higher than where it needs to be. This needs to be a little lower here towards the bottom base of the unit. So if you have to snake this up and over, there's a good chance there's going to clog here or not drain properly at all, and you're going to immediately back up the water. The drain pan is very shallow in all ductless products, so any little bit of sediment, slime, lack of proper pitch is going to cause that water to back up very quickly, so we want to be mindful of that. And once the water's run out the building and run away, it shouldn't affect that anything, and then once it's down and gravity takes over and the water is just discharged naturally into the environment. So that's a critical measurement there to maintaining that proper pitch on the drain line as it exits the building. Got a vinyl drain tube here in this image. There's no clamp here. There's no sealant of any kind used. It's just that hose is just plugged right onto that piece and could easily dislodge and create that open drain into the wall or down onto the floor. Making sure that we keep the drain line nice and clean. We see here that it starts here and then up and over the line set. That creates a little bit of a pocket there, and water will collect in that area. Especially on a horizontal run, we've now created a vertical rise in the drain pipe. We want to make sure this drain pipe stays below everything else on the bottom so the water will have a chance to run down naturally. Never use filter dryers or sight glasses on an inverter type system. And that's not a true statement in the fact that we don't want to use them on ductless systems. Inverter systems, when it comes to unitary products, do require filter dryers and other components, although sight glasses are debatable, but that's for another training day. But none of these items here should be ever used with a ductless system. And for this reason alone, besides other related issues, no, it will cause a pressure drop in the system and cause potential restrictions. So remember, the line sets are saturation lines and not your typical warm and cold suction lines. They're both cold and different points of expansion. So we don't want to create any kind of restrictions. We want to make sure we have nice, clean, dry refrigeration lines. So removing the plugs, good flares, and we're getting to pressure tests and nitrogen charging here in a minute. But we're making sure that the refrigeration lines are clean, well run, and secure and insulated. Good flares. Can't speak on this enough. Making sure that we have a good cone, 45-degree cone. We send in a package with our manual and the remote a set of our own flares. You can use the factory flares, which is preferred, and making a nice clean connection with a nice clean flaring tool, working clean, working tight, and making sure that that refrigeration system is nice and clean, keeping free of contaminants and secure and pressurized at all times. Just an example of how to deburr a pipe and then properly flare with a flaring tool, making sure that the flare nut is put on before you flare. As a funny, how oftentimes you do a nice flare and then you go, oh my gosh, I forgot to put the nut on, or I put the nut on backwards. So you have to cut the pipe again and attempt to make another good flare. Although it's good for practice on the apprentice level, we laugh at ourselves and then have to do it over again. But making a nice clean flare is critical in connecting the two components and making sure that everything's coming out the way we expect it to. If you see here close up, there's a nice clean flare against the head of the valve, just below that top brass bevel. That's going to ensure that when we squeeze that nut down over these threads, that's actually going to compress that flare a little bit into that brass, and it's going to seat nice and flush. And that's going to create that nice pressure tight seal. And then using our properly rated torque wrenches, we're going to make sure those nuts are nice and tight, following the specified torque settings, using a backup wrench, whether you use the properly sized box wrench or an adjustable, monkey wrench, so to speak. The two grunt method, the old popular squeeze it until your palms hurt scenario, is not necessary. We want to make sure we're using our proper tools and meeting the proper torque settings for all of the different connections. Depending on the size of the pipe, you don't want to over tighten those joints and possibly crack and damage those flares or the valve. If you got to put plumber's putty or Teflon tape or some kind of goo on there to make sure those are sealed and tight, that's a no-no. And you want to try to make sure that you're not caught doing that, because all of that material could get into the pipe, get into the refrigeration system, creating nothing but headaches for you down the road. Could create a numerous number of restrictions, get into the compressor oil, get into the valves, creating all kinds of restrictions and refrigeration nightmares for the equipment and for you and your customer. We don't want to do any brazing work. Flares don't require any solder, any kind of brazing or anything like that. You don't have to weld on these valves. You don't want to melt the equipment. None of that is necessary with ductless equipment. Now to the over-important nitrogen test. Once we think we have good clean flares and our lines are nice and tight, we want to pressurize them. Rather than using the all-expensive and environmentally contaminating refrigerant, we use nice nitrogen. A good high pressure test will confirm that we don't have any leaks and that we're ready for charging of the system. Pressure tests at 500, 550, 600 PSI is recommended. We can use our soap bubbles to verify if there's any leakages in the valves in the system, and making sure that our line set connections are secured. Making sure that we hold it for a minimum of 30 minutes or more, and then discharging the nitrogen appropriately, and then running our vacuum pump to draw down our system, and making sure that it's nice and clean, ready for refrigerant. Why is a nitrogen test at 550 and 600 PSI important? Micro leaks are common, especially in flare joints. Very difficult to see at any point. We had an example here where our technical assistance center had a call where the contractor left 350 PSI in the system for over a month. And then he commissioned the system, and it ran for 3 months. Same contractor received the call that the customer said the system was no longer cooling. Upon inspection, oil was found at a flare joint and the system had no charge to recover. So obviously there was a major leak there, and 350 PSI was not enough static pressure to overcome the micro leak. But after the system running, it ran the charge and pushed the oil and everything out through the faulty flare, resulting in the service call and ultimately, a call for warranty. So that obviously is a good example of why the extra pressure to test at a high nitrogen level is important in trying to identify any of those micro leaks within the system. Proper flaring techniques, as we went over before. Good flare should hold and exceed sometimes 550 PSI. A good cone, the 6 small threads holding anything back. So that little piece of copper and the brass and everything there, that's all you've got, making sure that the refrigerant stays in the system, and that's all that's holding that together. So we want to make sure everything's clean and tight and ready to go. Flaring is imperative, as gone over and over again. Completely seal the system. Unclutching flaring tool is the proper tool to use. Different flaring tool equipments are out there, and you can choose which you're comfortable with, but making sure that you have a perfectly bearish-free 45-degree cone, and that you have good clean flare nuts, good clean threads, can ensure that the line sets are going to be done correctly and that your system is going to be ready to go and give you no problems once you commission the equipment. Flares done in this manner, like I said, will not require any sealants or thread compounds or anything like that. So the flare, take your time, focus on that, making sure you have good connections, and you'll be ready to go and ready to roll. Wiring connections, 1, 2, 3, and G. Various labels and nomenclature. You may see letters. You may see LN, S as signal, and G. There may be a variety of other nomenclatures used out in the industry for specific wiring landing positions. You can color code each wire. You can go 1 is black, 2 is red, 3, whatever you use, black, white, red, green as ground always. In some instances, you may not be using those color-coded wires. You may have a brown in there. You may have a yellow with a stripe, but making sure that you correspond the proper terminals with the proper landing spots of the other wire. Oftentimes, you'll install a unit, you'll power it up, and you won't get any response from the equipment. There's a good chance that your landing spots for your wires are incorrect. I would go back to that and start fresh and look over your wiring connections and make sure everything is landed properly, and making sure that you have the proper supply voltage, making sure that you're running your 208, 230 volts or your 115, 120 volt equipment powered and supplied wired appropriately. As always, a good ground from panel to ground to disconnect to equipment to head unit is critical in making sure that the appliance has a good earth to ground and that the equipment is grounded throughout the entire system. And in some cases, you may have to drive your own ground rod if there are none, or if there's not a good ground within reach of the equipment. As a good ground is essential for the printed circuit board to stay free of harsh EMI or RFI signals. Grounding requirements are stated in every manual published, not just Friedrich's. So get in the habit of making sure that you run good grounds and making sure all your wiring connections are nice and clean and tight. Similar to stressing the importance of how the refrigeration piping should be done, good clean wiring connections, clear system through will ensure that your system is going to be ready when when customer needs it and when you complete the installation. An example of a ground rod here. Grounding for digital circuitry. Effects of no earth to ground. No electrical noise suppression. There's no radio frequency interference suppression. There's no voltage surge suppression. There's no ground fault. Digital logic noise problems can cause data corruption, meaning that you'll get disruptions in the signal, or you'll get weak or interfered bypass, which may create equipment failures, nuisance calls, nuisance operation, erratic and sporadic operation. A variety of things can be created by the digital data corruption. Lightning and surges. This is a big one. Aftermarket surge protectors can be used on the disconnects and the equipment. If you anticipate either high voltages or possible lightning strikes, use a surge protector. This is just a good industry recommendation, not only for ductless equipment and unitary equipment, but maybe some of your other major electrical components within the home. So if you're looking into this, it's definitely a good recommendation and should be considered at all times. Triple evacuation, back to charging and evacuation every time. Some guys say, well, I put nitrogen in it for 30 minutes, I'm good. Well, you may want to double check and follow these procedures. This will help you ensure that the system has been completely evacuated and clean, ready to go. You've ensured that you've done the proper flares, you're using good copper, you followed all the proper installation methods related to the line set equipment. And first you're going to do your initial pressure test, and then you're going to purge. You never want to return it to atmospheric pressure. You want to make sure that your vacuum pump can pull that material out. If you break the vacuum and you draw in contaminants by mistake, unknowingly bringing in moisture or air, that could create a nuisance problem for you that you're not realizing. And then following more vacuum with 2 additional evacuations, and then leaving the vacuum down to your 300 microns until it stabilizes, or hold under 500 microns for at least 30 minutes. Now you've ensured yourself and the equipment that you have a good clean system, and you've done all you can to help yourself ensure that this installation and startup is going to go well, and then you're ready to charge your refrigerant. Vacuum test, you can check for bubbles. See if you have any leaks under a vacuum. If you lose the vacuum or if you notice any bubbles, you're going to have problems and you want to revisit your nitrogen pressure testing process. And then leak and moisture detection, holding for 30 minutes after a micron reading is stabilized. You're going to see if there's any spikes in or loss of vacuum charge or vacuum hold. And you're going to see this range here. Some scales are different, but you're going to see as it increases, you lose, and you can gain an increase of contaminants in the system if you have leaks. Additional refrigerant charge, bringing in the use of our digital scale and confirming the installation and operation manual for the exact values of each system, making sure that you're using the system charge by weight using a refrigerant scale and calculating the base charge of the liquid line length with the pounds per foot multiplier, one pipe, one way. So if you have, give you a quick example, if you have a 40-foot pipe and a system is based off of a 25-foot run, you have to equate for an additional 15 feet, whatever the chart scale is for that model number, you would add 15 feet times whatever the rate value is for that system. Sometimes it's 0.22 or whatever the consideration is for that mark. You would multiply that amount of refrigerant times the number of feet, and that will give you how many extra ounces or pounds of refrigerant you need to add to that system. Now our floating air ductless Fast Pro. Fast Pro is our great design knot. When we see here in the image, you see the cassette on the right is the old style, and the cassette on the left is the new style, or the head on the left is the new style. See how this flap, this bottom, completely opens up, gives you access to the blower wheel here, the drain line, and the wiring connections. The next slide shows you that it gives you much faster to install. We can reach the line sets here. We can have the wiring connections here. All of this without that plastic in the way. We don't have to prop up the head and stick a block of wood under there and all of that stuff. And, you know, we can get good access with all of that open underneath. And the estimated minutes to install the new head design is 14 minutes as compared to the old style of 23 minutes, roughly 40% faster to install. Gives you more space to work. It's 45% faster to clean as well, roughly to have to take everything apart, wipe all the veins down, clean everything, take the cover off, in some cases, remove the lid, the panel, the washable components. All of that used to take about roughly 40 minutes, sometimes longer depending on the access to the equipment. So if you put yourself in a good position where you can have access to the unit that you installed, or hopefully somebody else installed, the newer head will give you that 22-minute advantage using the Fast Pro design. It gives you access to all the veins underneath and gives you the ability to remove the bottom chassis. All of that comes apart. If you had to replace any electrical components under here, remove for the blower motor, repair the drain line, repair any of the tubing underneath, gives you full access and can cut that down to about 50%. The cradle here, which encompasses the drain pan, the blower wheel, the blower motor, the drain line, also removes and it gives you access to the evaporator coil for cleaning as well on the backside and underneath, making this a fully serviceable floating air ductless unit. And that's the presentation I have for you gentlemen today. Thank you for your patience and your time and your attentiveness. We'll take questions as well. I'm sure if you could remember us on our social media pages, and I'm turning it over to you, Jared.
Thank you, Mr. Palmer. As a reminder, if you have questions, the easiest way to submit a question is to move your cursor over your active window and in the conversation box, enter your question into the Q&A. Looks like, Mr. Palmer, we do have a couple in here, and it looks like our product manager for Ductless, Chris McGee, has been answering them, but I'll go ahead and address them. First question is, what is Friedrich's position with mechanical fittings, Smart Lock, Zoom Lock, and ProFit. And it looks like Mr. McGee has answered them. It says, if done correctly, they should be okay. Installation of aftermarket accessories are left to the installer's expertise. So thank you for the question there, Steve. David Benjamin has a question. A lot of contractors I talk to don't believe in triple evac. They claim they could get down to 500 microns and hold it for 30 minutes. All is good. What is a good way to explain the need for a triple evac? And I'll send that one to you, Mr. Palmer.
Best way I can say it is it's tried and true experience. If they're willing to accept the responsibility that they've done a good job, then yes. But, you know, all the refrigeration books, trade schools, teachings, field experience will tell you that a double check or a triple check never hurt anyone to ensure that the system is done correctly. Yes, they want to be responsible for micro leaks and things like that, then that's on them. They would have to ensure them to their customer that, you know, they did a good job. So I would hate for them to have a mistake or have a problem down the road, especially when it comes to warranty or equipment breakdown, and that being an issue. So it really comes down to personal preference. It's something that I have practiced after 20 years in the field, where I, you know, made the mistake early on of not following my my protocols and procedures, and on some specific jobs, it created problems for me. You know, where I did have micro leaks, and I was the guy that had to go back and find the refrigerant leak and find the oil leaking down the side of the sheetrock or the drywall or whatever the issue is, because, you know, I didn't do a proper pressure test. You know, I've personally been there, so I know the all too not nice situation of what you can get into and the costs related to it. So I think it's important. It's definitely a good practice to get into. Nitrogen is cheaper to lose than refrigerant. Making sure and ensuring that the equipment is sound and that I don't have any warranty claims against me or my company is another sound judgment. So any of that information should help, you know, support why it's necessary, and that they want to make sure that they ensure that they did a good job. So yes, in some cases, a vacuum pump will pull down to 500. Short line set, you know, it might be quick. You know, an extra pressure test, that's even going to be quicker because you don't have to fill up the volume of refrigerant line. But when you have a system that's a 4 zone system or branch box system, or, you know, commercial application with long extended line sets, you want to take some time in ensuring that that system is done correctly. You don't want to go and have to check, you know, 16 or 18 connections or whatever the volume of head units you have in that system and how many flares you have to redo. So, you know, it's important.
All right. Thanks, Mr. Palmer. Great answer. I think as an OEM, we always appreciate a double or triple evac. Oftentimes, when we get a call into technical support, we lead with that question. How many times did you pull an evac and how many microns did you hold it to? So I appreciate the answer. That cleans out our current meeting chat. Just as a reminder for those of you late joining or just joining or rejoining, if you have a question for the Friedrich team, simply move your cursor over the slide, and in the conversation chat, you can enter your live question in Q&A. All phones are currently muted, so that makes it hard to do an audio question, but we'll certainly allow a couple more minute or two here for additional questions. Let me check the chat box again, Mr. Palmer. One just, well, I think that's Mr. McGee answering David's question. So no new questions coming in. With that, I will close today's webinar. I would ask that Mr. Palmer and Mr. McGee please hold on the line for a minute or two at the conclusion in case we do get an off webinar question in the Q&A chat box that we can address. For those of you who joined us today, thank you for your time and attention. We appreciate you taking time out of your busy schedule to attend Friedrich Ductless training. And as always, we appreciate your business. With that, I conclude today's webinar. Thank you all for joining. Mr. Palmer, Mr. McGee, please stay, and this will end recording. Thank you, guys.